In this example, we will anti-differentiate arctangent divided by x squared. So looking at our integrand, I see no obvious algebraic manipulations or substitutions. The integrand does not fit any of our standard forms. And furthermore, I don't see any more subtle substitutions either. So the next thing on our list would be to try integration by parts. So when we try integration by parts, we need to come up with a choice of u and dv. And recall, whatever we choose to play the role of dv needs to be something that we can easily anti-differentiate. So in this case, we have the choice between arctangent and 1 over x squared. And 1 over x squared is the function that we can easily anti-differentiate. Its antiderivative is minus 1 over x. So u would be arctangent, and du would be 1 over x squared plus 1 dx. So integration by parts tells us that we take uv minus the antiderivative of v du. So that would be minus 1 over x, arctangent of x, minus, and note our integrand is going to contain a minus in it, and if we pull that out front, minus a minus is a plus, and it will be 1 over x squared plus 1. And at this point, we're unsure how well this integration by parts is going to work out. The thing we have to think about is, can we evaluate this resulting integral? And the answer is yes. It is a proper rational function. The denominator factors as a linear term times an irreducible quadratic, so we simply need to do a partial fraction decomposition. So let's go ahead and perform the partial fraction decomposition to the side down here. So we have 1 over x times x squared plus 1 equals a over x plus bx plus c over x squared plus 1. So one linear term, one irreducible quadratic. So 1 is equal to a times x squared plus 1 plus bx plus c times x. And here I'm just going to go ahead and expand everything out on the right. So to start with, on the left we have 0x squared plus 0x plus 1. On the right you have a plus b x squared, a cx, and your constant term is an a. So at this point we can go ahead and equate the corresponding coefficients to set up a system of equations. If you look at the x squared term, we have that a plus b must be equal to 0. The linear term tells us that c is equal to 0, and the constant term tells us that a is equal to 1. And going back to the first equation, if a is equal to 1, b is equal to minus 1. So now let's go ahead and use the partial fraction decomposition to evaluate this resulting integral. The minus 1 over x arctangent x is carried down, and what we are integrating is, let's see, a over x plus bx, so that would be a minus x over x squared plus 1, and the c value is 0. So minus 1 over x arctangent x plus the antiderivative of 1 over x is the natural log of absolute value x minus the antiderivative of x over x squared plus 1. This is once again something you can just write down and tell me what it is, or if you're not immediately seeing it, you can go ahead and use a substitution. If you let w be x squared plus 1, that shows us that we need an extra 1/2 natural log x squared plus 1, and we finish with a plus c.